I will go over I'll show all of the devices, but some highlights for like how we have really added capability to the catalog. There's a new lowest price DAQ device for PXI. So if you're on the PXI platform, we have a new multifunction DAQ device that sets a new price floor for the catalog. We have a new PCI Express board that sets a new high bar for how many channels on a single device. 208 channels on a single device. And then we have a new highest resolution for PCI Express. So we've added an 18-bit board to the lineup. So those are I would say the outside of the envelope of what we've added, but we've also filled out some of the catalog. The yellow highlights show you what's new and basically why it's new. So we created some variants that don't have analog output. And real quick, I think I mentioned this, but when we say a multifunction DAQ device, that family of our catalog, it's a single device that combines 10-volt output, 10-volt input, and digital, mostly TTL, and some counter timers. So wrap all of that measurement capability into a single device, and then stamp it on PXI, PCI, or USB, and that's a multifunction DAQ device. So all of these have a combination of those channels. So we created some new ones that don't have analog output on it. So it would just be analog input and digital. So if you're not using analog output, now you don't have to pay for it. So it's another feature option. And then the high density options, 80 to 208 channels of single-ended channels for a single PCI Express device. If you are doing like research test beds and you have just tons of sensors all over the place that you need to measure, that's a good option. So like a lot of 0 to 10 pressure cells, or you're just measuring a whole bunch of voltage across a research test bed, that's good. The other hotspot for high density boards would be manufacturing. So if you have an industrial PC and you want to test multiple devices at the same time for manufacturing throughput, that's a cost optimized way to get high channel density. Flipping over on the PXI side, we've got some speed variants. So remember the highlights are like, hey, why does this new board exist? So we've got some speed variants. And then if you look down at the bottom, we've added a new best resolution row to our PXI Express catalog. Because the 18-bit board is going to be the best voltage measurement in this multifunction DAQ category. If you say, hey, Brett, I want to make a 10-volt measurement or a 1-volt measurement, what's the best thing you got in your mioDAQ family? Across all the buses, it's this board. It's this 18-bit board. It's not just the resolution. It's 18 bits, which is nice. It's not just that. We also look at all the gain settings. So you can set the range on this from 10 volts all the way down to plus or minus 100 millivolts and 5 spots in between. So you can really dial in to minimize the noise impact on the measurement. And speaking of noise, this particular board, it's one of the few boards in the family, has a 40 kilohertz front-end filter. So to further clean up your signal before it is converted digitally, you can enable that 40 kilohertz front-end filter. Is there any isolation on these channels? No. So this multifunction board is not isolated. We do have isolated boards, but this is not one of them. So a couple of demos. This one doesn't move. These are screenshots. I wanted to show visibly like what's the difference between 16-bit and 18-bit? How much does that filter make a difference? So I took one of our 24-bit precision analog output devices for PXI, and I generated a really small sine wave, 200 microvolt sine wave. And then in the same PXI chassis here, I have one of the 18-bit boards and then one of our 16-bit boards. And so that's the two connector blocks that you see stacked up. One is the 16-bit input and one is the 18-bit input. So similar, same family, they're both multifunction DAQ devices, but one is the 18-bit. On the top, you can, probably because I told you it was a sine wave, like you can see that it's a sine wave, or maybe you can make it out. But on the bottom, with the 18-bit resolution and that 40 kilohertz front end, does a lot of the heavy lifting there. You can see a much cleaner sine wave. So that's really, dialing in the input range and adding that front end filter gives a really clean measurement. I hopped over to Diadem. So this isn't the sine wave. I shunted the AI plus to the AI minus channels because I wanted to just kind of measure some ambient noise. And it wasn't that noisy, so I then I used a function generator, created a square wave, and I basically tangled that square wave wire all over that shunted plus minus cable just to induce some noise. So what you're looking at in orange, this fuzz right here, it's basically plus or minus 150 microvolts of noise that I was able to generate on that signal. That is with the filter off. So this is the 18-bit board, but the filter's off. So right now the 18 bits has got a lot of noise that it's measuring. Turning on that 18-bit, or the 40 kilohertz filter, I was able to drop the range down to about 2.4 microvolts of noise. And then just quick side note, a lot of engineers are red-green colorblind, and so orange-blue is apparently a really good contrast to stand out. So fun fact, hopefully everyone can see that. And then on the bottom, there's just a histogram. I dropped this into Diadem real quick, so I was able to just drag the TDMS files over, and it cranked out a histogram using the same number of bins and range. So this should be an apples to apples compare. But yeah, just a huge difference in where the error is on with the filter versus without. And you can see that both visually, but then also mathematically. For those of you that may not be familiar with it, this is our latest and greatest bus-powered USB DAQ device. It's also in the multifunction DAQ family, so input, output, digital, and counters. If you bought this right when we released it, we've actually added some new software-enabled features for it. On the digital side, you can select the voltage ranges. So there's 16 digital pins that can be input or output, and now you can set the threshold. So you've got 5, 3.3, 2.5, and 1.8. There's a CJC that's always been there, but we've enabled it in software, so whether you're doing a DAQMX task in LabVIEW or Python or using FlexLogger, you can now do a thermocouple channel with a CJC enabled. And then there's a user-controlled LED and a smart pin on there, and we have examples and YouTube videos that show you how to use those. So just want to make sure everyone's aware. Sometimes the features, the software features come in later editions. And then if anyone does OEM, so they're building DAQ systems into either their own device and shipping it out to customers, or sometimes I see what we call a pizza box. People will build test stations and build everything into a 1 or a 2U box, and they prefer something that's more board level. We have an OEM version of mioDAQ available, and the real difference is these connectors. So the I/O connectors are a ribbon cable instead of the spring terminals that we have on the one that's actually in metal. And then quick call out, not just for the OEM, but for mioDAQ itself, 2 and 10-year calibration intervals. So when you go in the specs, you will see different accuracy and noise measurements depending on how long it's been since you did an external cal. If you've done one within 2 years, you've got one column. If you are outside of 2 years, go to the 10-year column, and you can see what to expect. Okay, the second most popular vote was CompactDAQ. It's near and dear to my heart because I've been around long enough that I was on the team that launched CompactDAQ just about 20 years ago. So CompactDAQ is a very well-established hardware platform, and it continues to grow in popularity. And I think we're at over 80 different modules now for the platform. So we're gonna talk about the 2 newest ones. I'll do a quick refresh on the chassis that I talked about last year. So I'll start basically with what's the newest. We've got 2 new 10-volt modules. And this particular module, it's very similar to how we design our multifunction DAQ devices, but it's input only because it's modular, so you can pick and choose. This module, the 9204, is 16 channels single-ended or 8 channels differential. So if you're using 1 pin to ground, you can do 16 channels. If you're doing pin to pin, then you divide by 2 and you get 8 channels. It has multiple gain range, multiple input range settings, just like a lot of our multifunction DAQ devices. 16-bit, 250K, and it's multiplexed, so as you add more channels, you divide that 250K by the number of channels. This is a variant of one of our most popular modules. So we were very confident adding this one to the family. Again, it's gonna provide a new entry point. This is a half order of the 9205. The 9205 is twice the channels. And the 9205 is one of the most popular modules that I just referenced. And it's the same specs, but double the channel count. So if you need even higher channel counts, know that the big brother to the 9204 can go up to 32 channels. And then on the other side, simultaneous. So we've shifted from a single A to D converter and muxing through all of the channels to a simultaneous architecture that's going to give you 16 channels, plus or minus 10 volts, 200,000 samples per channel. So if you need 2 channels, each channel is 200,000 samples per second. If you need 10 channels, each channel is still 200,000 samples per second. I think you get the idea. And then both of these are available as spring terminals, which when you see the front of the connector have the latest ones have the orange pin tabs on the front. So these are spring terminals. You just stick the wire right in if it's like a solid core wire. And then if it's a stranded wire, you use a little push tool and you can open up the spring cage and drop it in. But we have a new connector type that I'll talk about in just a second. Okay, this is my new favorite connector type. So a lot of our modules most of our modules have options for the connector. D-sub, BNC, screw terminal, spring cage clamp. This new one is called a snap-in connector. And if you're familiar with like Wago lever nuts, I don't know if you've ever used those. Those are great too. There's a little lever here, and you open up the lever, and it releases the signal wire. But it also opens up a spring. And so now if I want to connect a wire, this one has a ferrule tipped onto it. I can just stick it in. And did you hear that click? So you get a nice little auditory signal. And then you're not going to be able to see this, but there's a little green tab that sticks up. So you also get a visual indicator. And then you can also feel it. There's little haptics to it. And this is in there. And this meets our shock and vibe spec for C-Series. So that is available on 10 of our existing C-Series today. It's a different part number. It's not like you're ordering interchangeable parts for the front end. If a module has 3 connector options, it's 3 part numbers. And so all the ones here are 3 or 4 channel modules. So some of them now you have like 3 different connector options, BNC, screw terminal, or the snap-in connector. And then on the chassis side, I mentioned this, we announced this last year. So Ethernet chassis with a single port, and then USB chassis with a USB Type-C connector. So a refresh on both the Ethernet and the USB chassis side. If you have, from a USB perspective, there's really no effective reason to buy the USB Type-B chassis. From a driver and a technology standpoint, they're the same under the hood. So you get the new cable. Ethernet, we still have the two slot Ethernet chassis, and we have now a 2-port Ethernet chassis, and this new single port Ethernet chassis. So you could start with a single port Ethernet chassis, and then if you want to expand your system, add a 2-port, and you can daisy chain. And the single port could be the end of your chain or part of a star configuration. The new chassis, we've tested and they've passed to higher level shock and vibe. So the previous chassis were not rated for the full C-Series spec, but now with the new USB 4-slot and 8-slot, not the 1-slot, but the 4-slot and 8-slot are the full minus 40 to 70, and then 50 to 5 Gs. This is our ultra rugged DAQ device, but it has lab quality measurement. So you can not only have it get wet, you could submerge it to 1 meter for 30 minutes, so you don't have to worry about enclosures as much. You still get the synchronization capability that I just talked about, 1 microsecond up to 15 hops, and you get really high quality measurement. There's 4 devices right now covering these measurements. So you've got voltage, you've got sound and vibration, so accelerometers, microphones, you've got strain gauges, load cells, pressure transducers, and then thermocouples. Those are the devices today, and they're feature rich. They're all 24-bit. With the exception of thermocouple, they're all 102.4 kilosamples per second. So this uses one of those delta sigma converters like we were just talking about. So you can set the rate. There's several different clock to choose from, but you can basically call your own rate. And then any channel on the same device or any channel between devices that are on the same network are going to synchronize within 1 microsecond. Other features to call out, they all have filtering. So you can enable or disable filtering. Some of them let you choose the type of filter. So the strain gauge one, you can select like a brick wall anti-alias filter, or you can turn on a Butterworth filter and cut it at like 500 hertz and go really low noise. Or you can even do a comb filter, so you can notch out what you want to do. And then you can kind of think of these, if you're familiar with CompactDAQ, that's a good approach to think about this kind of measurement, but it's more rugged. And because the device has more power, like a single C-series module is limited to 1 watt. Like that's how much power we spec ourselves, kind of like an internal standard for that. These devices have access to more power, and so you get more measurement performance. And also things like powering 10 volts on load cells, right? So you can actually power more sensors straight out of the device. So the network, this green wire, if you can see what I'm holding here, this green wire is a network cable. The plugs are M12, so it's a standard industrial connector type. And we have accessories for basically all of them. So if you want to, you can build your own sensor on the M12 and wire it up, kind of like what I've done here. Let me take this off. This is a load cell, and then I've got the M12 connector here, and then this comes apart, and so I can solder, or in some cases screw terminal inside of this and build a very rugged connector type that it doesn't need as much consideration out in the field. It becomes a little bit more hardened for sure. There's 4 parts per million per degree C gain drifts on the IEPE device, and then 5 microvolts per degree C of offset drift. So just really, really stable quality measurements that you're not going to get from like other vendors. There's other boxes out there that are IP67 DAQ devices, but we take the lab measurement quality outside. So we did a teardown, but because it's potted, it's got that potting material inside. We can't take it apart once we manufacture it and send it off and get it potted. So we cut it in half with a chop saw in our machine shop. You can see both how heavy it is, but then also you can see the material inside. That's good for keeping the components in place, so that it helps with the 100G shock rating, but it also helps pull some of the temperature away from the boards, giving us, contributing to that stable drift.